Right, definite integrals. I think for the first time ever, when I say this is going to be a really quick video, and then I said interview. Why did I want to say interview? A really quick video. I think I actually mean it. So let's get straight in. Everything we did with integration in P1 was all about looking at it as like the opposite of differentiation. And it was getting from your like dy by dx back to your y equals equation, or just simply integrating something. With definite integrals, we are starting to use the fact that integrating the equation of a curve finds the area underneath that curve. What finds the area underneath the curve between the y-axis. And we do that by putting limits onto the integrals, which is what these little numbers are on the integral sign. So we are going to integrate 4x cubed between the limits 5 and 1, and it will give us a value. It will give us a number as an answer rather than an expression. It also means that we don't need to worry about the constant c at the end. I'll talk a little bit about that as we go through the question and how to answer it. For now, I'm going to move, I think I should have left this a bit further down, so I've got plenty of room. So let's put that there, and let's have a look at the first one. So the first thing we need to do is actually integrate the expression. So 4x cubed, we're integrating it, we are increasing the power by 1, so it becomes x to the power of 4, and then dividing by the new power, so dividing by 4. 4 divided by 4 is 1, so it's just x to the power of 4 when it's integrated. We put it in these square brackets, and we write the limits on the outside of the brackets. You do have to do that. It's part of the correct notation, and it means that it's, even without the plus c constant at the end, it's still correct because we're going to evaluate it between 5 and 1. And all we're going to do with those numbers is substitute in 5 into the integrated expression, and then substitute 1 into the same expression, and then subtract the two values. And that's why you don't need c, because you're going to work out what x to the power of 4 is. Sorry, you're going to work out what 5 to the power of 4 is, and you're going to work out what 1 to the power of 4 is, and then you're going to subtract them. If you had a c in both of those, because we're subtracting, they would cancel each other out. So we don't need to write it in because it's going to cancel itself out anyway. So let's do it. For this one, because it's quite a simple expression, it's not too difficult, but just for continuity's sake, I'm going to write 5 to the power of 4 in one bracket, and then I'm subtracting 1 to the power of 4 in the other bracket. We write them out like that to avoid making any mistakes with negatives and things like that, because we all know they're easy to make mistakes with. So we kind of substitute the limits into the expression separately in two separate brackets. We work them out and then we subtract, just to eliminate the places where we can make mistakes. But anyway, 5 to the power of 4 is 625, minus 1 is 624. So that is the value of the integral 4x cubed between 5 and 1, evaluated between 5 and 1, 624. That's it. That's all you need to do. Let's have a look at the next one. So again, we're integrating x squared plus 1 with the limits 3 and negative 3. So we've integrated first, so we increase the power by 1, gives us x cubed, and divide by the new power. So we've got x cubed over 3 plus x. And again, we don't need to worry about having a plus c at the end. We're going to put the limits on the outside of those square brackets, and now we're going to evaluate it. So we're doing 3 cubed over 3 plus 3 minus negative 3 cubed over 3 minus 3. Work those out. 3 cubed over 3 is 9, plus 3 is 12. So I've got 12 minus, my negative 27 over 3 is negative 9, minus 3 is negative 12. which would give me 24, because minus minus. Have I done that right? I think so. Yeah. Yeah, and that's it. That is literally all you have to do. Obviously, this is the introduction to how we then use it to find area. But it's important that you know how to find a definite integral so that you can find the area underneath a curve, or between a curve and a line, or between two curves. But yeah, that's how you do it. The last thing we're going to look at is like a problem solving question where you've got an unknown within the expression. So given that p is a constant, and the integral of 2px plus 7 between 5 and 1 is equal to 4p squared, show that there are two possible values for p and find these values. So the first thing we're going to do is integrate 2px plus 7, which would give me x squared divided by 2 leaves us with just the p, plus 7x. We're going to evaluate it between 5 and 1, which means I get 25p plus 35 minus p plus 7. So I've got 25p minus p is 24p, and 35 minus 7 is 28. So 24p plus 28. I know that that is equal to 4p squared, so I put 24p plus 28 equal to 4p squared. I put everything on one side, minus 24p plus 28. I can also divide by 4 to make it easier to solve. Minus 6p plus 7. And now I can solve it. So plus 1 minus 7. So I get 0 is equal to p plus 1 p minus 7. So p is equal to negative 1, or p is equal to 7. And that's it. Those are the two possible values for p. That's it for definite integrals. The next video will be how to use a definite integral to find the area between the curve and the x-axis. But for now, that's all you need to know. That is how you find a definite integral. You integrate it, you put in the limits, you subtract them, and that gives you a value. And you can use it to solve these lovely problems as well. That's it. Hope it made sense. Have a lovely day. Thank you for watching.